Hello, my dear students of class 10. This is Priyanka Upadhyay, your physics teacher, and today we are going to solve numericals from the first part of ICSE class 10, chapter 2, work, energy, and power. Okay, the first numerical is a body when acted upon by a force 10 kgf get displaced by zero point 0.5 meter. Calculate the work done by the force when the displacement is in the direction of force. Second one, at an angle of 60 degree with the force and normal to the force. Okay, the first one is when the displacement is in the direction of force. What happens? Okay, first we need to convert this force into SI unit. Okay, so it is given that the force is 10 kgf. So what we will do, we will convert this into Newton. Okay, so how to convert? Multiply this 10 kgf into 10 Newton. So you will get 100 Newton. So this is the force acting on the body, and the displacement is 0 0.5 second. Therefore, the work done is force into displacement in the direction of force. Okay, so W is equal to F into S. When the displacement is in the direction of force, work done will be equal to force into displacement. Therefore, work done is equal to force is 100 Newton into displacement is 0.5 meter. Therefore, the work done is 50 joule. Okay. In the second part, they ask us to find the work done. Okay, when the displacement is at an angle of 60 degree with the force. Okay, so work done is equal to force into displacement. So we have the formula W is equal to F into S cos theta. So theta is given. Theta is how much? 60 degree. Okay, W is equal to force is 100 Newton into displacement is 0 0.5 into cos 60. Value of cos 60 is 0 0.5. Therefore, the work done is how much? It is 25 joules. Next, find the displacement when the force is, when it is normal to the force. When the displacement is normal to the force, we need to find work done. So work done is equal to force into displacement in the direction of force. So we know that when the displacement is normal to force, work done will be equal to 0. You don't need to solve this. And the displacement is in the direction, when the displacement is normal to the force, what happens? Work done will be equal to 0. So let us evaluate this. So work done is equal to force into S cos theta. So F is 100 Newton into S is 0 0.5 meter, cos 90. Cos 90 will be 0. Therefore, work done will be 0. Second numerical, a boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meter in 5 seconds. So we need to calculate the force of gravity acting on the body, the work done by him against the gravity, and the power spent by a boy. Okay, see, a boy of mass 40 kg climbs up. So what happens here? Force is in the direction of displacement. He is applying force upwards and he is moving upwards. Okay, therefore, okay, so mass of the boy is given. We need to write the given things. Vertical height moved by a boy is 8 meter. Time taken by a boy is 5 seconds. So force of gravity acting on the boy will be force is equal to mass into acceleration due to gravity. Mass is 40 kg and acceleration due to gravity is, we can consider it as 10 meter per second square. Therefore, the force acting on the body will be 400 Newton. Second one, work done by a boy against the force of gravity while climbing. Okay, work done by a boy is equal to force into distance moved in the direction of force. So when he is moving upwards and He's applying the force in the direction of displacement. So therefore work done will be equal to force into displacement. Substitute the values, you will get work done is equal to 3200 joules. Next one, power spent. So power we have formula, that is work done divided by time taken, and work done is how much? We have found the work done. Work done is 3200 joules divided by time taken is 5 seconds. Therefore the power spent by the boy is 640 watt. Third one, a man spends 6.4 kg energy in displacing a body by 64 meter in the direction in which he applies force in 2.5 seconds. Calculate the force applied and the power spent by the man. See here, work done by the man is 6.4 kilojoule. So work done is given, distance is given. So we need to find the force. Okay, work done is given, distance is given, so we need to find the force. We need to substitute these values in W is equal to F into S. Okay, so after the substitution, when you transform, you will get F is equal to W divided by S. So what is the value of W, that is work done? It is 6.4 kilojoule, that is 10 raised to 3. Okay, divided by 64. This 64 meter, that is displacement. So the force, you will get the force as 100 Newton. Second one, you need to find the power spent, okay, in HP. Okay, power spent. How will you find power? It is work done divided by time. So work done is how much? 6.4 into 10 raised to 3 divided by 2.5. You will get 2560 watt. But you need to convert this answer in terms of horsepower, that is HP. So we know that 1 horsepower is equal to 746 watt. So we need to find 2560 watt is equal to how many horsepower. So you need to transform this and you need to do the cross multiplication, and finally you will get the answer as 3.43 horsepower. Please solve the numericals in your book. Fourth numerical is a weightlifter lifted a load of 200 kgf to a height of 2.5 meter in 5 seconds. Calculate the work done and the power developed by him. So the value of G is given, it is 10 Newton per kg. Okay, so now, okay, so before finding work done, we need to find the force because it is given in kgf and we need to convert it into Newton. Okay, so the force is mass into gravitation, acceleration due to gravity. So therefore 200 into 10 is 2000 Newton. So the distance given is 2.5 meter. Therefore time is 5 seconds. So work done, so you need to find the work done first. So work done is force into displacement. So here work done is in the direction of force, so displacement is in the direction of force. That is the reason we are using W is equal to F into S. So W is equal to, the value of force is 2000 into displacement, that is distance is to 2.5 meter. Therefore the work done is 5000 joules. And power developed, in the second part we need to find the power developed. Power developed is equal to work done divided by time taken. Okay, so work done is how much? It is 5000 joules divided by 5 seconds. So the power developed is 1000 watts. Okay. Fifth numerical is a machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. Calculate the energy spent by the machine and the power of the machine if it's efficient, if it is 100% efficient. So first we need to find the energy spent by the machine or work done. So that is force into displacement. So now work done is, force is how much? Force applied is 750 Newton and that through a height of 16 meter. The displacement is 16 meter. So therefore work done is 12,000 joules. So the power spent is nothing but work done divided by time taken. However, we have found the work done. So substitute the values and you will get the power spent as 2400 watts. The next numerical is an electric heater of power 3 kilowatt is used for 10 hours. How much energy does it consume? Express your answer in kilowatt hour and joule. Okay, so we need to find the energy consumed. So they have given the power. So energy consumed is equal to power into time. So therefore energy is equal to power into time. So power is how much? 3 kilowatt and time is 10 hour. So energy spent is 30 kilowatt hour. So we need to convert it in terms of joules. So 1 kilowatt hour is equal to 3.6 into 10 raised to 16 joules. So 30 kilowatt hour is equal to how many joules? So here what we need to do, we need to do the cross multiplication, and finally we will get the answer as 1.08 into 10 raised to 8 joules. The next numerical is a water pump raises 50 liters of water through a height of 25 meter in 5 seconds. Calculate the power of the pump required. So G, acceleration due to gravity they have given, and density of water they have given it is 1000 kg per meter cube. Okay, so what we need to find? The power of the pump required. So here the volume is given in liters, so we need to convert it into meter cube. So it is 50 into 10 raised to minus 3 meter cube. So the density of water is how much? 1000 kg per meter cube. So we need to find mass of water. So mass of water is equal to volume of water into density. Okay, because density is equal to mass by volume. So mass is equal to volume into density. So substitute the values here. You will get mass of the water as 50 kg. So work done in raising 50 kg of water to a height of 25 meter. Here it is 50 kg. So what we need to do? We need to find the work done. It is against the force of gravity. Therefore, work done is mgh. So W is equal to mgh. So power, we need to find the power. Power is work done divided by time taken. So work done is mgh divided by t. Substitute the values here. You will get 2500 watts. Next numerical is a pump is used to lift 500 kg of water from a depth of 80 meter in 10 seconds. Calculate the work done by the pump, the power at which the pump works, and the power rating of the pump if its efficiency is 40%. Okay. So first we need to find the work done by the pump. So work done in raising 500 kg mass to a height of 80 meter against the force of gravity. So here work done is mgh against the force of gravity. Therefore work done is equal to mgh. So substitute the value, you will get the work done as 4 into 10 raised to 5 joules. Power at which pump works. It is work done divided by time. Power is work done divided by time. So power is mgh divided by t. So your answer is 40 kilowatt. Okay, now we need to find efficiency of the machine. So the formula for efficiency is useful power divided by power input. So the efficiency given is 40%. 40% is nothing but 40 divided by 100. So therefore it is 0.4. So substitute in this formula 0.4. So useful power is how much? 40 kilowatt. 40 kilowatt divided by power input. Okay, so power input is how much? 40 kilowatt divided by 0.4. It is equal to 100 kilowatt. Okay. Next one, an ox can apply a maximum force of 1000 Newton. It is taking part in the cart race and it is able to pull the cart at a constant speed of 30 meter per second while making its best effort. Calculate the power developed by the ox. So here the force is given. Force is how much? 1000 Newton. Velocity is given. Velocity is how much? 30 meter per second. Okay. So for power we have one more formula, that is force into velocity. That is power is equal to force is 1000 into velocity is 30. So power is 30,000 watt. It is nothing but 30 kilowatt. Next one. The power of a motor is 40 kilowatt. At what speed can the motor raise a load of 20,000 Newton? So power is given. So we need to find the speed. Okay, so we have the formula, power is equal to force into velocity. Power is given, it is 40 kilowatt and the force is 20,000 Newton. So velocity is equal to power divided by force. 40 kilowatt divided by 20,000. So you will get the answer. It is 2 meter per second. The speed is 2 meter per second. Next. Rajan exerts a force of 150 Newton in pulling a cart at a constant speed of 10 meter per second. Calculate the power exerted. So the power exerted by Rajan due to force is how much? Power is equal to force into velocity, that is 150. Force is 150 Newton, velocity is 10 meter per second. So therefore the power developed is how much? 1500 watt. Now 12th numerical. A boy weighing 350 Newton climbs up 30 steps, each 20 centimeter high in 1 minute. Calculate the work done and the power spent. So, see here, the total distance covered we need to find. He is climbing each 20 centimeter high in 1 minute. So total distance covered in 30 steps is 30 into 20 centimeter. Distance we are calculating, 30 into 20 centimeter. So he covered 600 centimeter, that is nothing but 6 meter. Work done by the boy in climbing. Okay, so it is force into distance moved in the direction of force. He is climbing up and he is applying the force in the upward direction. So therefore displacement is in the direction of force. So so we can write work done is equal to force into displacement. So force is how much? It is 350 Newton and displacement is 6 meter. Okay. So therefore, work done is 2100 joule. So now we need to find the power developed. Power developed is nothing but work done divided by time taken. Work done is how much? 2100 joule and time taken is 60 seconds. Okay, so therefore the power developed is 35 watt. Next, question number 13. It takes 20 seconds for a person A of mass 50 kg to climb up the stairs, while another person B of same mass does the same in 15 seconds. Compare the work done and the power developed by person A and B. See here, the work done by two person A and B is independent of time. Hence, both will do same amount of work. See, work done is independent of time. So what is the given thing? It takes 20 seconds for person A of mass 50 kg to climb up the stairs, while another person B of the same mass does the same in 15 seconds. So we know that work done is nothing but force into displacement. Here that it is independent of time. Therefore, we can say that the work done by both the persons is how much? Same. So therefore work done by A divided by work done by B. So it is 1 divided by 1, that is nothing but the ratio is 1:1. Second one, we need to find the power developed by the person A and B is calculated as below. Okay. So A takes 20 centimeter to climb the stairs while B takes 15 seconds to do the same work. Hence, B does the work at a faster rate than A. See here, A takes 20 seconds to do the work and B takes 15 seconds to do the same work. Therefore, we can say that the B is doing the work faster comparative to A. Therefore, more power is spent by B. So now we need to find the power developed. Power developed is equal to work done divided by time. Okay, so power developed by A divided by power developed by B is nothing but 15 by 20. Why it is 15 by 20? The power developed by A, if you take 1 divided by time, it is 1 by 20 divided by the power developed by B is how much? 1 divided by 15. So it will come in the numerator again. So it is, so if you take the ratio, it will be 3 divided by 4, that is nothing but 3 is to 4.